Fast, come in, sit down. Take attendance. Hi. Hit anywhere? Huh? Huh? Yeah, go on. Hey, fast, sit down, right? Okay, so 2022 page 2023 not yet released yet. So when it released, I'll auto stat for you lah. Right. So number 9. Okay, move closer to solenoid and got deflection of galvanometer. Okay, be careful because galvanometer normally is 0 at the center, right? And then normally when we do voltmeter and ammeter, the 0 is on the left, correct? Voltmeter or ammeter lah. So this one, can you please tell me if this is the center, this is A, this is B. Which one has greater deflection? A, B. Okay, thank you. Can someone close the door? Thank you. Yeah, actually A lah, correct lah, because 0 at the center. But see, if voltmeter, ammeter, 0 on the left hand side. Which one deflect more, A or C or D? C or D? Yeah, so you can draw it out. I advise you to draw it out. So it's D, deflect more. All right, deflect. Deflect means move more from 0 or from original. So that year, many students wrong because of they didn't realize the 0 start from center or start from the side, right? Now this one, electromagnetic induction, we just learned. What is meant by electromagnetic induction? Five Sandalia, I just asked this morning. Okay, lại Hannah kỳ tạ mà. Tell me half also can, right? Yeah, very good. Yeah, so magnetic induction, always think about magnetic flux first. Yeah, so we say there is induced EMF. Actually, it's voltage lah, right? In case you forget, actually EMF is voltage. Okay, induced means when a wire cut with magnetic flux. Okay. So if you read textbook, oh, it's a long sentence, right? It's really long sentence. Your textbook will say when there is a rate of change of magnetic flux. But now from 5, actually they accept cut lah, because cut means moving and cutting, moving and changing. So we use the word cut enough lah, short sentence, easy to remember. So this is the answer. Yeah, the answer is production of induced EMF from relative motion between conductor and a magnetic field, or when conductor is in a changing of magnetic field. Actually means they are, or means actually these two sentences are the same thing, got relative motion. So if you use cut, yes, can replace it. Is in changing magnetic field. Also can say cut magnetic flux. Okay, so it's easier for you to remember. Okay, so now next, based on diagram 9.1, state the polarity at X and Y. X and Y. Yeah, you think first, 10 seconds. Yeah, actually it's about Lenz's law, a sad story, sad love story. Get it? X is? No. Yeah, very good. So now, tell me who tell X is north. Yeah, thank you. Not sure. Okay, sure. Okay, yes, X is north. Yeah, sad story. Means the magnet is a boy. Normally lah. Normally boy is more active lah. Okay, then solenoid is, yeah, is a girl. All right. So the boys tries to go into the heart of the girls. But the girl says, no, not so hurry. We know each other first. So they tried. So the girl tried to repel it. All right. So since here is north, here is south. All right. So we say X. Yeah, you can write. Actually, you should write on here lah. Okay, but never mind. Up to you lah. Since here got space, you can write lah. In real exam, right here. Yeah, the test pad is ready for you. Okay, so no need prepare test pad already. Just write inside. Hey, wait, I'm not sure this time how. Let me confirm to you. But in real exam, they ready already. Don't worry, got many pages enough. Okay, so now X is north. So Y is south. Okay, so now determine the direction of current that flows through galvanometer. So always sensitive to N. Okay, and state deflection of galvanometer. Okay, so 2 marks. Number 1, how is the current goes into galvanometer? Clockwise or anti-clockwise? Okay, if you don't remember, doesn't matter. What should you do? You add an arrow at the end of the knob. Now, can you see it? If you are still not sure, please add the clock here. This is 9 and 3. 9 go down, 3 go up means anti-clockwise, right? Anti-clockwise means, actually here got the hidden coil. Can see that? Can see the hidden coil? It's behind. So actually is your right. If you see from here, right go up, left goes down. So how is it? Oh, sorry, my fault. I draw the wrong way. Here. It's like this. All right. Actually, they are coiled like that. So up and down. So actually the current go down here, go into A. See, they purposely label AB for you. So we say current flows from A to B. Or actually in exam, they also accept from left to right. But since they got AB, we use AB lah, from A to B. Then don't forget one more mark, deflection of the galvanometer. Okay, so what's your answer? Deflection means this one will deflect to your left or to your right, or deflect to A or deflect to your B. Okay, like A, like B. Okay, actually, you know what? Both also can. Because actually on galvanometer also got positive and negative. So if you connect here positive, negative, yes, it will go to the right hand side. But if you connect negative to positive here, yes, it will go to the left hand side. As long as you say there is deflection done. So you can say galvanometer deflects to left or right, A or B, doesn't matter. As long as you say there is deflection. So your answer could be deflect to A, deflect to B, deflect to left, deflect to right. Down, up, down cannot. Up, down cannot. Up, only got left, right. Up, down cannot. Okay. But the current sure from A to B, all right? Then next, explain your answer in 9B, 1 mark. Yeah, answer. Anyone? Try. Yes. It's okay, you try first. Wrong, never mind, we correct now directly. So actually quite easy lah. Just say that just say that there is current flows. Actually, explain what? Explain why there is deflection of galvanometer. You can explain a few lah. Don't write one answer only, okay? So we can say there is induced current. Or if you say induced EMF, also can. And the current flows through galvanometer. That's why I got deflection. Understand? Or if you want to say the Lenz's law also can. The Lenz's law makes the current flows in clockwise rotation, anti-clockwise rotation. All right, now based on the concept of electromagnetic induction, explain how an induced current can be produced in the solenoid. Okay, here be careful. Since they say induced current already, so finally you cannot say induced current, but you can replace it by using, yes, induced EMF. So highlight, don't write this as your answer. Yeah. Okay, so now how? So actually, if you can write here lah, the answer here C. Okay, now we practice, we can write anywhere you like lah. Okay, so now actually how is it? So normally this kind of 4 marks question, the first sentence is an action. Action means you can see. Or we say, all of you learn in Bahasa Melayu isi tersurat, right? You can see. Then 2, 3, 4 normally is isi tersirat, means something about physics lah. So actually, what is the action if you want to make the deflection? You magnet. Okay, we can say put the magnet close to the solenoid. Can we use put? Okay, yeah, one more thing. Close. Can you see close? Yes, cannot use. Yes. If you use back push closer, sorry, no marks. If you repeat anything from question, no marks. So maybe we use other words, synonym, like English, very good one. Yeah, near to the solenoid. Don't use push, we say put, or we say carry or something. Do not use the word same as the question. Yeah, this makes you lost mark. Okay, then actually here got something we cannot see. What is it? Yes, it's the magnetic flux. So when you put magnet closer to the solenoid next, yeah, so we can say strong. You want to describe stronger or not? Am I? As long as you tell magnetic flux will, yes, cut the solenoid. So when solenoid is cut means the solenoid will produce, induce, can I say current? Why not? Yeah, question got it, got current. Question got current, we don't use. Use EMF. Use EMF. Yeah, so in SPM, they don't want you to repeat question. They want to assure you really understand the concept. You know, you use other synonym. All right, so now last we can say, this obey, what law is it? Lenz's law, correct? Not me. Okay, good. Yeah, it's Lenz's law. All right, if you spell wrongly, sorry, no marks. Okay. Okay. What short form? Okay, can. EMF can write short form. Okay. It's international symbol, can write short form. And don't forget, EMF is electromotive force, but actually it is voltage. All right. All right. So now next, induction cooker. Okay, actually, induction cooker is same as wireless charger. Okay, so your wireless charger here got the coil. DCC will produce magnetic. This one is magnetic flux cut on the coil in your handphone. Okay, then they will produce induced current here and charge your handphone. And same thing as the induction cooker. Induction cooker. Induction. Okay, so same thing as induction cooker. This one inside got coil. Then they will form what? They will form magnetic flux. Then we put a pot here. The pot got soft iron core. They will produce eddy current. Eddy current will make the pot hot. All right. And while the magnetic flux cutting on it, it will vibrate. So just now and yesterday, did I show you 5 tulips? Not yet. Okay. You will feel the vibration because the magnetic flux cutting on it. All right. All right, 5 tulip very pity because last week we lost 2 hours lesson. Okay. Okay, so now induction cooker is here. Means the coil actually is under the, it is in the induction cooker. So now, what is the type of power supply? AC or DC? Yeah, AC. Why we should have AC? Yeah, so that we have changing of magnetic flux. Yeah, it's the changing of current cause the changing of magnetic flux. It's like this from 5 chapter. Oh yeah, oh sorry. Wrong video. Can you see at DC the magnetic flux constant, but AC the magnetic flux changing. Yeah, we want the changing of magnetic flux. Okay, if you want, you also can, if you want to go further, you also can see this lah. It's in your telegram, right? Okay. Yeah, so now this is the coil under the induction cooker. So it's producing magnetic flux. Okay, so it's actually hitting the pot, under the pot, right? So this one you can see the telegram. Okay, so now, what is the material for the surface of a cooker? Yeah, ceramic or steel. Actually, ceramic better because ceramic can insulate heat or heat insulator. We say hot slower. Hot slower actually means what? Means low specific heat capacity. Sorry, high. Okay. Okay. Then, actually, you should look at this part. Determine the most effective induction cooker to cook food more effectively and economical. So your reason cannot write this lah, right? Then now, what is the material of the base of the pot? Yeah, should be iron. The best is soft iron. Why soft iron? Huh? Low specific heat capacity is minor reason. The major reason is when we magnetic flux cut on iron, what happened? Yes, there is induced EMF. Yes, correct. Or we say there is induced current. And actually that current, we call it as there is eddy current. So eddy current actually can do what? Can become hot. Yeah, there are. Sorry? Good heat conductor. Yeah, actually, yes, it's one of the reason. It's one of the reason, but it's the minor reason. Actually, induction, the most important thing is they cut and get induced EMF and hot, make the pot hot. Yeah, so the main criteria they want here is you show magnetic flux cut on it, it got induced current for this case. Okay. If you want to put, you can put good heat conductor lah. But it's a minor reason lah. Minor reason. You can put a few reasons, understand? Don't put one only. Okay, then next type of electromagnetic coil should be copper or nichrome. Why not nichrome? Huh? Okay, yeah, for this one induction, wow. Yeah, this is copper coil. But this one, if electric current stuff, this one we use nichrome. For me, thank you very much.
funny.
真的假的？
哎，
哦，
好的，很好吃。
谢谢你。真的假的
不是
？OK。One lead, give me. Thanks for her. Thank you. Thanks for bringing. Thank you. Okay, so if this one need to be hot, yes, we use nichrome. But this one we want more current to flow through so that got more magnetic flux. Yes, we use copper. Understand? But actually, when we do until here, only one answer only lah, copper lah, right? So copper, why copper? Low resistance, low resistivity, more current to flow through. All right. So it's almost same as the transformer 啦。可以看到吗？你要来前面吗？I just write the short form. Yeah, more current flow. Why so blur one? Okay, low resistance, more current. Okay, for short form, for practicing exercise, we use short form. But in exam, please write everything full. Understand? Okay, so 10 marks like that. Okay, yeah, one more. I encourage you to write 1, 2, 3, 4, and 5. 5 is your choice. So your choice would be L. Because this time when I mark your paper, that many people write until 4 only. 2 column, 3 column, up to you, doesn't matter. But many people write until 4. Some, they will add sentence. I choose L because blah, 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 blah. It's okay. But some forgot. I think I marked 3 classes. Got at least 5 people forgot to make a choice. So 5 out of how much? 5 out of 90. So then you forgot to choose, you lost 1 mark lah. I also saw someone directly write choice on top, or someone they make 4 column, they write L. I also can. But for me, I would like to always write 5. 1, 2, 3, 4, 5. Number 5, I put choice, then won't forget. Understand? So lost mark in careless way lah. Okay, now this one is electric circuit. Okay, so see, just now number 9 is Form 5, Chapter 4. This is Form 5, Chapter 3. So last time, the old type of SPM, number 9, they will give like Form 4 chapter, right? Number 10, Form 5 chapter. But now we cannot predict lah. They just simply come out lah. Okay. Okay, so now look at this. When I see voltmeter connect in this way, means it's measuring EMF or potential difference. Huh? When voltmeter connect in this way, EMF is measuring EMF or potential difference. Yes. See, this, you look at the dry cell, battery, then at the end of the dry cell, connect to voltmeter. Actually, they are measuring EMF, right? Now, state the function of voltmeter. Yes? Can I say to detect voltage? Yeah, answer is no. Yeah, please use the word measure. Measure. Okay, every meter rule, galvanometer, voltmeter, ammeter, barometer, manometer, whatever meter, they are used to measure. Okay, if you want to say voltage in Form 5, okay? If you want to say EMF, can. If you want to say potential difference is the best lah. One more time. Exercise I put short form. In exam, please write full. Okay? Now, based on diagram 10, what happened to the ammeter reading and the voltmeter reading when switch is turned on? 2 marks. Means ammeter reading 1 mark, voltmeter reading 1 mark. How? Like Ethan, when switch is turned on means you close the switch. So be careful here. Switch is turned on means you close switch. Yeah, so there. Yeah, so we say ammeter show a reading, can. Voltmeter. Voltmeter, what? Voltmeter reading how? Increase. increase. Okay, if you write increase, then I'm so sorry you get wrong. Because voltmeter reading should decrease. Let's say here got 9 volts. When no current flows through, it's supposed max EMF supposed 9 volts. But when current starts to flow through, then when the current comes out, the voltage will drop. Let's say drop to 8.8 volts. The 0.2 volts drop. Why the voltage drop? If you just say resistance not enough, you should say internal resistance. Okay, so we say why? Okay, so ammeter got reading. Mean okay, your answer because there is current flow, correct? Just now Ethan said there is current flows. There is current. Yeah, there is current flow lah. Okay, then why decreases? Because we can say voltage drop. Then you tambah lagi. Voltage drop means voltage drop to overcome the internal resistance. Okay. The internal resistance. Okay, so yeah. Ammeter, okay, because they are asking reading, they are not asking deflection. If you say ammeter deflect, ammeter deflect. I'm not sure, I think cannot. But if you say ammeter reading increases, yes, can. So be careful what they ask, all right? Yeah, thank you. Very good. Let me see answer first. Oh, okay, can. Potential difference voltage here. Wait. Ammeter shows the reading increases. Oh, cannot. Okay, needle or pointer deflects. Can. Good. Can. As long as you say there is current, can. Okay, so now from here, can you please help? Okay, I think no criteria here. Can you read through first? Can you read through first? Okay, so now they are talking, careful. So here you got 4 circuits. The last sentence say EMF for each dry cell is the same. Let's say 1.5 volts. Power rating for light source is the same. So this one not affected. So there are what? There are 4 identical dry cells. What's the meaning of identical? Same. 2 types of light source, 3 filament bulb and 3 LED. Okay, LED actually is diode lah. We will learn in chapter 5. All right, so now, which one do you think? Okay, wait. Since you have overlooked already, read here first. Is there any criteria mentioned in the sentence? Please highlight them. Criteria 就是讲你不可以拿来做 reason. You cannot use it as reason. Okay, 来延伸 criteria. Yeah, brighter light and then not easily flammable light source. Yeah, good. Okay. So if you cannot say brighter light, what else you can say? Yeah, higher light intensity. Very good. Higher light intensity. Okay. Now I give you 1 minute. Which one is the best? You can discuss. S. Okay. All right, so now I believe all of you will cancel filament bulb first, right? Yeah, so you left 2 here. Which one? Right? R, S. S. All right, yeah, correct, R. Okay, explain the suitability and choose the most suitable circuit. Same thing, you can draw the table. Okay, means, okay, in SPM, if you want to answer 2, can. Okay, they will choose a higher marks one. But in trial, you don't do that, please. We have short time to mark only, right? Okay. And then I don't tell others because they might spend times on 2 questions, but they will get lower marks. But I believe all of you can answer 2 questions and enough time lah, right? All right, so or you just choose. Okay, which one to choose? You choose the 10 marks questions. Which one you are more confident lah to score lah, right? All right, so now type 1, connection of type 1 is, actually, what is this? Yes, this one, see, from positive to negative, negative to positive. Can see that? So actually, this is called series circuit. Then this one is parallel circuit. Actually, it's a combination of parallel and series lah, right? Now, okay, so here got 4 criteria. Number 1, you can say which one wherever. Number 1, LED. Number 2, low resistivity wire. Number 3, connection of the wire. Number 4 is, hey, I don't see number 4. How? Huh? Yes. Yeah, the arrangement of LED. Yeah, number 4. Okay. You can see this is series. This is parallel. So actually here got 2 parallel. One is battery. One is, what is it? Bulb. Yeah, bulb. Okay. So here is the video. If I'm not mistaken, this. Okay, here. Can you see when battery connect in parallel way, they can use longer, but you can see the voltage is not increasing. Voltage, we say voltage increasing, we represent it by using the height. So if you connect in series, can you see connect in series? Then it will become higher and higher, then more energy carry around, right? But when they are connecting in parallel, when they are connecting in parallel, you can see the voltage is not increased. They just, the brightness is so only, right? So now we look at this. Okay, number 1, why LED light, Dylan? Yeah, we can say greater efficiency of energy or power, lasts longer. I think can, but write as minor reason. I believe all of you can write more than one reason. Jot down already. Less heat produced can. What else? Can I say brighter? Yeah, cannot write brighter because they mentioned already. So, but you can say greater intensity of light. Yes. Okay, why low resistivity? Yeah, so that more current flows. What else? Low resistivity actually means, actually, yeah. So you can say low resistance. There are 2 different things. Okay, so write at least 2 reasons. What else? Okay, then next, number 3. The parallel and why parallel battery? Okay, actually, like this, we can say lower voltage or lower EMF. Okay, because they don't want easily flammable. So the voltage too high, it might be flammable. Okay, lower EMF. What else? lower. Just now we got something about internal resistance, right? Yeah, we can use back here. We can use back here, lower internal resistance. When it's parallel, resistance smaller. But it's battery, so it's internal resistance. So if you just write resistance, sorry, no marks, huh? Must be internal resistance. Okay, number 4. Light bulb parallel, why? The light parallel, why? Huh? Yeah, here we can say lower resistance. Oh, sorry. Can say lower resistance, but also cannot just write lower resistance. Is lower internal for battery. This is, yeah. This one called effective resistance. Outside battery, we say effective. Yes, please. Same density, same intensity. Okay. Same again. Sorry. Okay. You know what? Actually, if you arrange in series, they also equal intensity but dimmer. Yeah. So actually, both equal intensity. This one dimmer. So actually, this one we will say brighter, but cannot say brighter. We say greater intensity. If you want to say greater equal intensity, okay, but you must mention greater intensity. Actually, this one also equal intensity, but dimmer. This one equal, but brighter. Okay, why? Always remember the brightness come from voltage. So we say higher potential difference lah. Hey, why tita? Huh? Done already, huh? Huh? 哎，写完了啊，你的手已经放这了。OK, good。啊，什么？还没有抄完。And I'll give you answer next week. You all try do first. I'll give you answer next week. You do and check your understanding, right? 啊，全部。9 of August. Okay, now. Yeah. Okay, so in the beginning, I get the instruction finish syllabus by end of August lah. But now recently, we must all finish by 8th of August. Don't worry, actually, we almost done already lah. Okay, almost done lah. So, chapter 7, I will make one more class, but I will consider finish. Consider. Okay, chapter 6 done. This Sunday I will have class with chapter 5 about transistor first. Okay, then this week and next week I can teach diode and capacitor in school lah. Okay, then we consider by 8 can finish lah. I still will, after that, we just focus on answer the question. From the question, we check back our understanding, all right? All right, 9, continue. I hope you are discussing about physics. The rest, please quiet, all right? All right, so now this is a 9-volt of dry cell. Okay, light. 9-volt of dry cell and internal resistance is 0.5 ohm. So small r lah, small r. And what is this connection? Series of parallel? Yes, parallel. So we use 1 over r equals to 1 over r1 plus 1 over r2. And actually, I advise you to write in this way. R equals to 1 over R1 plus 1 over R2 bracket powers of -1. Okay. Why? Because most people at the end forgot this is 1 over R. So actually how to do this is 1 over 0.5 plus 1 over 0.5. You will get 2 over 0.5. And you will get, okay, powers of -1 means what? Switch. Yeah, switch. Or you use 1 divided by 2 over 0.5. Understand? Or you, what is it? 20, 54, 20. Yes, then you 1 over 4. Okay, can I leave answer in this way, 1 over 4? Yes, cannot make. Yes, if you write fraction directly wrong, yeah, please write it as decimal, can? Okay, so now, see, effective internal resistance. So effective internal resistance will be R equals to 0.25 ohm. Okay? It's around here. Yeah, effective internal resistance. Effective internal resistance. Okay, what's the reading of ammeter? Okay, can you tell me what is it AC or DC here? Battery means DC lah. So when DC we use Ohm's law, V equals to IR. So V is, I'm sorry, cannot use V equals to IR. Why? No, because something is mentioned here. Internal resistance is mentioned, so we use which one? First one. Thank you very much. Number 5. Thank you very much. Use number 6. Okay. So it will be epsilon equals to V plus I small r. Okay. And actually we forget something. Let's write in 4 first. What? So 9 volt is what? We got 9 volt, we got internal resistance. Actually, total, effective means total actually. Okay, so 0.25 ohms small r. Resistance of mini fan is 60 ohm. Resistance of mini fan. When the resistance outside of battery, it will be capital R. Then they want ammeter reading means I equals to a question mark. What do you think 9 volts? Is it V? Yeah, if you write V will be wrong because actually it's EMF. What's the symbol for EMF? Epsilon, right? So when you feel it's hard to calculate, write in 4 first. So 9 equals to they don't give V or how? Huh? Yes, you modify your formula. So you can modify your formula first. Epsilon equals to I capital R plus I small r. So epsilon equals to I R plus, yeah, open bracket, thank you, R plus R. Yes. So epsilon equals to, sorry, then we can substitute already. So 9 equals to I 60 plus 0.25. So I equals to 0.1494 ampere or 0.149 ampere. What do you think? 0.15? Wrong. Okay. Yes. Yes. 因为它是 parallel， 所以它不需要加 parallel 长这样子。Can see? The voltage is not some. If series, then you can see the voltage increase and increase. This is in series connection. But if they are in parallel, you can see they no need sum up. They no need build up the voltage. Because they are parallel. Right? Okay, now 11. Read it yourself and do it, and all of you start and go, right?
different value or 通常
如果是 different，通常跟最高那个
是一个5
跟 ten 对然后那个5就会拿 ten 的 EMF，所以它会消耗的比较少。通常没有问题的，那个大学才有问题的。Okay, number 1, if you're not A, you're not sure, never mind first. Please do B 1, 2, 3, 5 marks. And I will see your work. Okay, can write short form. Okay, if you cannot see the thermometer properly, it's like this lah. It's like this. Then this one down here is here and here. Get it? I make it smaller lah. Okay, in SPM, it's clearer. If got color, they also printed color for you. Yes, in SPM, they show you color diagram. Oh, 我知道你们看不清楚，我画给你们，可以吗？这样子可以吗？我知道你们看不是很清楚，可以吗？ Okay, so if you forgot the definition, actually you can. Last year also I gave you this. If you forgot definition, you can check back. What's that? 好像没有拿过，最好是没有。
没有，老师。
没有Yeah, my fault. Okay, my fault. I'll photostat this for you. Sorry. I'll modify a bit and give you. Okay, overall, very good. I can see. Last time, module intervention effectively got, I think 12 people lost their book. And everyone took the free photostat one, but haven't give me money yet. If you haven't paid, pay to me. Okay, so this one, okay, I tell you what, SPM, sometimes the diagram got something wrong. So if you really use your ruler to measure, you will find out which one is longer. Yeah. Yeah. So actually, if you find out one is long, actually they are the same lah. Actually, answer is same. Answer is same. Initial temperature is the same, but because the diagram wrong, one is longer than another. So if you use ruler to measure, yes, we also accept because diagram wrong. Understand? Okay, why like that? Because when the teacher set the question, they just give a rough diagram. The people who in charge will find another person to draw the diagram. But the people may not know physics properly. You know lah, the art person normally not good in science. So that's why they got a little bit different. Actually, like last year got 4 big mistakes lah. Okay. So if you really measure your diagram, you find out, hey, this is longer. You want to say it's higher, also can. But actually, they are equal lah. Understand? Okay, so this one is higher, and I saw your everything. Okay, very good. So now just, what is physical quantity? Everything can measure in number, like length, like mass, like time, like power, are all can. But now they are asking kept constant. So power, okay. Time, okay. Mass cannot, Okay, very good. Temperature. Directly wrong. Because you see temperature increase what? Increase more, increase less, also increase what, right? Huh? 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 Environmental temperature not affect so much. It must kept constant, must be the physical quantity. If you don't fix it, It changed a lot. Ah, acidity. What he said? Can specific heat capacity can, density of water can. Okay, come on. Okay, now. This one. Can you do first? This one. This one many people miss concept when I mark. You all read properly and write. I encourage you to draw up. Encourage you to draw up. Okay, I read your answer. Yeah, most of you very good. So the key actually is here. So I also advise you to highlight send heads up faster. Did they say anything about freeze? No. So if you talk about freeze directly, wrong. So actually what they want is they want sand and sea water only. Yeah, when I mark, yes, a lot of people miss concept. Yeah, so this is the answer. 是咯，我也觉得很凉。Yeah, so sticky water can then with a big curve. By 是这样一个啊，来这边啊啊，yeah, okay, so number one, if you mention specific capacity of sand lower or seawater higher, they consider 1 mark. You write 2 also 1 mark, they consider 1 mark. Okay, actually, heat energy absorbed is the same. Heat energy absorbed is same amount. So if you mention less energy, yeah, actually I also will make that kind of sentence. Okay. And then if got any formula or name, you write it down. Since you say specific capacity, then you mention the formula. Yeah, you mention formula sometimes, not every time, but sometimes for mark. Then you tell what's the relationship between specific heat capacity. So is specific capacity inversely proportional to, actually what this theta, we should write delta theta. What is delta theta? Yeah, change in temperature or rise in temperature. So it is not just temperature, it is rise in temperature. Yes. Then we say rise in temperature of sand higher than rise in temperature of seawater. So here go 1, 2. So here go 1, 2, 3, 4, 5. For 5 sentences, we accept maximum 4 lah. So actually you can write more sentences lah, understand? Yeah, do not worry. Many people score 1 mark here during that year. Yeah. Yes, you must mention rise in temperature. Okay. Yeah, 1 more minute. Okay, this one like just read the sentence. Like just read the sentence first. I tell you what needs to be. Take attention. Okay, it is a green building concept. Not green, but green building concept. Green building concept means building that gives a positive impact on climate and natural environment. Okay, so now, using appropriate physics concept, such as the use of material. Use of material and appropriate design to increase ventilation. Apa itu ventilation? Yeah, airflow inside. And especially ventilation means hot air flows out, hot air rises, cold air sinks. So do you know why on top of our classroom up there got hole? Now they seal actually. Yeah. Why last time got hole on top? Yeah, ventilation, hot air rises go out, cold air go in. Now we seal because got aircon, right? And ensure the temperature in the house is not high. Your proposal must include specific heat capacity of material, type of material used as wall and roof, and the number of windows and the design of the house. Can you see actually here got 1, 2, 3, 4, and 5 characteristics. Okay. So can you please tell me properly what is number 1? Yeah, they want specific heat capacity of material of what? Yeah, of wall. Okay, then number 2. Yeah, type of material. Sorry, yeah, correct. Specific about the material and its type of material used by the wall and okay, yeah, so specific heat capacity of roof. Okay, then yeah, material. Actually, you can write like this lah. Material of wall, material for roof, and then number of windows. Okay, and then number 6, design of house. Thank you, rectangular. Rectangular, you will trap a fishing pool on top. Okay, so okay, so the design of house. When I mark, I find out most of them cannot answer this. I also cannot answer this. The answer is high design. I believe I also cannot answer this. Okay. Their answer is high roof or high ceiling. Okay. Okay, there are many answers lah. See, got air hole. If you put aircon directly wrong, because green concept means reduce the use of aircon. So put aircon directly wrong. Yeah. Greenhouse means use less electricity lah. Understand? Okay, greenhouse is means you never install any electrical appliances. You also will feel it's cool already. After I Google only, I get the idea. You never install anything, you feel cool already. Even though around there is hot, right? Okay, so that's all for today. Okay, thank you, class.